morning will be more and solvation due to solvation. 1 degree amine is more stable. And then we started the chemical reaction in which we did this. No, it is about the hydrogen bonding and all. Okay. We were about to start chemical reaction, that is basically your basic strength. So let's start the chemical reaction. And the first part is very, very important. And in here, I'm going to show you this part. The first one, that is basic character of amines. See, this is basic character of amines. So I already in the previous class I told you that the basic strength or character is directly proportional to plus I, directly proportional to plus R, inversely proportional to minus I, inversely proportional to minus R, as well as we can write directly proportional to Kb. This is base dissociation constant. If the value of base dissociation constant of a base is very high, then it is more basic. And we can write inversely proportional to pKb, it is inverse of Kb. Then comes inversely proportional to Ka, this is acid dissociation constant. Then comes your directly proportional to pK, reverse of or inverse of K. Is that clear? Now see, if a base which is amine, 1 degree amine, is going to react with an acid that is HX. So what will be the product? Basically, the product will be salt. Are you saying anything, Firaz?
No, sir.
Okay. So see, this X will be eliminated in the form of negative and this as a positive. And since this will act as nucleophile because it has a lone pair, so it will attack here and it forms RNH3 positive, and here it will be negative and it is a salt. Okay. The bond between this and this is ion. Now the next reaction we are going to take an aromatic amine, that is your aniline. This is your aniline, NH2. If you are going to react this with HCl, again the same thing will happen. Same process. This will be basically negatively, so it will be negative, positive, and this is a lone pair, so it will attack here. So what will be the product? You can say this is basically an anilinium chloride, we say. So it will be NH3 positive, positive because nitrogen donated electron to hydrogen and there was HCl minus, so it will be like this. It is also a salt, that is its name is anilinium. Anilinium. This is your aniline. So please do write it. Let me have water. Just let me know when you are done with it. Let me know when you are done.
Yes, sir. Done.
Very. Now, when we are going to see the basic strength, first of all, if the basic strength we are going to see in two phases. The first one is vapor phase, or you can say the gas phase, gaseous phase. And the second one is basically aqueous phase. That means it is present in water, aqueous phase, where hydrogen bonding will take. So in vapor phase, it will be seen that tertiary amine is most acidic. Then comes your secondary amine, and then comes your primary amine, and then comes your NH, NH, NH. See what happens here. Tertiary amine, that means nitrogen is here, and all the three bonds of nitrogen will be like this. And in secondary, you know, it will be like this, and in primary, it will be like this. So we already know that R is having a characteristic or properties of plus I. That means electron donating group. It is from electron donating group, and we already know that the one which donates electron will be more basic. So as you can see here, it will gain electron from three sides, then two sides, then one side. That's why tertiary amine in vapor phase will be greater in tertiary amine in vapor phase will be the most acidic, sorry, basic, then secondary, and then primary. Are you getting my point? Firaz.
Yes, sir.
But in aqueous phase, we expect the same order, but it doesn't take place. The same order will not be there. It depends upon the alkyl group, which type of alkyl group nitrogen is connected with, because there will be other factors that will come into play, like solvation, like steric hindrance. If you're going to see for this in aqueous phase, before starting this aqueous phase, I would like to write this. You know, this is your primary. This is your primary. And since nitrogen making 4 bond, that's why it will have positive charge. This is 1 degree. Then comes your secondary. That means basically your positive charge. And then comes your tertiary. Tertiary. Primary, and then secondary, and then tertiary. So if nitrogen is making 4 bonds, so it will have positive charge. Yes or no? So can you arrange them in decreasing order of extent of hydrogen bonding in water and order of stability of ions by solvation, and order of stability of these ions by solvation. So what I want to know is that which of these amine is will have the most hydrogen bonding, and due to this hydrogen bonding, it will be more stable by solvation. That means you are going to mix with water, it will be soluble, then the process is known as solvation. So can you tell me which one will have the most hydrogen bonding? Primary, secondary, tertiary?
Primary.
primary. Primary will have three hydrogen bonding, as you can see, three hydrogen bonding. Secondary will have from two side hydrogen bonding, and tertiary will have the one hydrogen bonding. So this will be the order. In previous classes or chapters, you have studied that the base which has a stable conjugate acid will be more basic. Have you studied this? Acid base, acid, conjugate base. Firaz? Firaz?
Yes.
So what I want to tell you is that the stable conjugate base, if the conjugate base of an acid is more stable, that means that conjugate, sorry, if the, wait a minute, I'm just, see, if you have got an stable conjugate base, that means the acid from which this stable conjugate base comes, that acid is more acid, more acidic. Are you getting my point? In the same way, if
Yeah.
you have got a very stable conjugate acid, that means the base from which this conjugate acid comes is very, very basic. Is that clear?
Yeah.
Now you can see if hydrogen bonding is here stronger, that means it is more stable. Yes or no? Yes or no?
Yes.
That means it should be more, the primary amines should be more basic in aqueous phase. Yes or no? So there are two
Yeah.
factors come here, come into play. That is, the first one is plus I effect, and the second one comes with this hydrogen bond. And it depends upon the which alkyl group you are using, either methyl or ethyl or anything. So please do write it, then I will show you and we'll move to that.
Done, sir.
Very good. You see, I'm going to give you a question. Actually, I'm going to explain because there will be variation due to these two factors. The one which dominates will be more best. So if I'm going to give you this, and it's very easy to learn, C2H5 whole twice. Can you tell me which degree of amine it is? Primary, secondary, tertiary. And you have to remember this. And then there comes CH3 whole twice NH. Which degree of amine is not ordered? This is 2 degree, this is 3 degree, this is 1 degree, 2 degree, degree, 2
Sir,
degree.
you are lagging, sir.
Am I lagging now? Let me
Yes.
switch off my. Am I lagging now? Firaz,
Yeah, your voice breaking.
still breaking?
Now it's okay.
Okay. So Firaz, if you have ethyl as a R, that is alkyl group, and methyl, so in ethyl, secondary amine is more acidic than tertiary, and then primary amine comes, and then amine this is ammonia. And in if methyl, R is your methyl, then secondary is now also the most acidic, then primary, and then tertiary. This is because of that two factor that we discussed due to the plus I and the solvation. So the one which dominates are more basic. So in this way, the ordered I write, and you have to keep this order in mind. It's very important. Now I'm going to give you this question, which is very easy. This is your aniline. This is your ammonia. So we have a class on Tuesday, right?
Yes, sir.
Let me know when you are done with it.
Done, sir.
So can you answer me in this? Which one of these are more basic?
NH2 benzene.
Aniline or ammonia?
More basic.
What you just said?
More basic.
Yeah, more basic. Which one is more basic?
Ammonia then.
Ammonia is more basic. Since both have plus R effect or plus I effect, you can see. This is basically busy in resonance. Busy in resonance, and this can easily donate as compared to this. That's why this is more basic. Can I change the slide?
Yes.
Very good. Now the next reaction. Alkylation we have already studied in the previous chapter. So this is acylation. Acylation, that means you are going to react amine with acyl halide. And as I already told you that primary, secondary, and tertiary amine treated as different functional group only because they react in different manner with the same reactant. So we are going to do it for first primary, and basically here in acylation, in primary and secondary, the reaction are basically same. Not for all, but for this, it is same. So you can see this is your primary amine, and you know nitrogen will have lone pair, and this is your what we say acyl halide, and you are going to do this reaction in the presence of this. I will also tell you a short trick of this question, this reaction. So it's very easy. As you can see, this is oxygen is more electronegative element, so it will attract or it will withdraw electron from carbon. So carbon will have deficiency of electron now, so this will directly attack here. Now see what we will get. So C2H5 was there and it was connected with the nitrogen, and nitrogen already has two hydrogen that I'm going to write on top, and there was a nitrogen on bottom. Now they will be directly connected in this way. Is that clear up to this? Now see what will happen here. Since chlorine is more electronegative, so it will take electron from carbon and it will be eliminated or go out. So oxygen will give electron to carbon. So there will be double bond between these two. So here how double bond will take place. C2H5, and then the most important point is that there will be positive charge on nitrogen that I forgot. Since nitrogen has donated one of its electron to carbon, and nitrogen is the third most electronegative element. That means positive charge on nitrogen is less stable, so it will take electron from hydrogen, and this hydrogen, which will be in the form of H plus, and this Cl, which will be in the form of Cl minus, so it will combine to give a byproduct that is HCl. Now what we will have NH. Now this will be C double bond O, and then CH3. This CH3 I'm going to write it. So this is what you have got, which is very easy. This is what you have. Okay, and you can see this is your amide. This is your amide. NH C double bond O, which is amide. Is that clear? So I'm going to write its name, which is N-ethyl ethanamide. And this is your ethanamide. Ethanamide. Is that clear?
Yeah.
I'll also give you a shortcut of this reaction, which is very easy. Please provide it. Let me know when you are done. Are you done with this?
Yes.
Very good. So see, there is a shortcut of this reaction which is very easy and we can do in a step. If you have this C2H5NH, that means I can write this as this, and then there is Cl I'm going to write, and this is your CH3. And if you are going to react this with base, so what will happen? It's very easy. So this HCl, you are going to remove this, and this is what you will get. So C2H5NH, that means you can write it like this, right? And C double bond O, that will be directly bond between nitrogen and this carbon. So this is what you have got. For secondary, the same reaction will taking place. So I'm going to do it directly in this way. You can see. And this is what you will get. So you are going to remove this HCl and in the presence of this, you will get C2H5 and then C2H5. And then you will be getting C double bond O HCl. So its name is basically N, N diethyl ethanamide. Diethyl ethanamide. So this is what you will get. Let me know when you're done. Let me know when you're done.
Does.
Very good. Now, we are going to react this with acid anhydride. And the reaction is quite easy. You can see this is your primary amine, and this will have a lone pair in which this is your acid anhydride. And its name is basically ethanoic anhydride. The common name, ethanoic anhydride. And this is your benzenamine luvate. Let me show you. This is H5NH2, which is benzenamine. That means basically aniline. This is your aniline. So what you are going to do? It's very simple. What you need to do, just this will have negative, this will have positive, this will have positive, this will have negative. So negative will go with positive. So I'm going to write this part first. As you can see, this is your C6H5 and then nitrogen and then H. And this positive will go to this negative. And this nitrogen will be directly connected with this. So there will be C, then double bond O, and then there is CH3. And you can see this is your CH3C double bond OOH. That means ethanoic acid. CH3C double O. And this will have a name that is N-phenyl ethanamide. N-amide. And this its common name is basically acetanilide. Acetanilide. So it's very easy, I think, right? Can you do this reaction? Let me know when you're done with. Are you done with this, Firaz?
Yeah.
Okay. So what you have got, you know that this
CH3NH,
and one
then
hydrogen. Yeah,
COC6H5.
very good. CH3, CH3NH, and then comes here.
CH3NH, then CO.
Yeah, CH3NH, and then CO, and then here comes need this NH. This is right. This is right.
Yeah.
Now the next reaction is this carbylamine reaction. Amine reaction. So see, this is your carbylamine reaction in which basically we do isocyanide test. It is also known as carbylamine reaction and isocyanide test. So if you have either aliphatic and aromatic and in aromatic it should be basically aromatic primary amine. Secondary and tertiary does not react, so primary amine. On heating with chloroform, that means CHCl3 chloroform, and ethanolic, that means alcoholic potassium hydroxide, forms or produce isocyanate. Or we can say carbylamine test, a carbylamine. And these are basically foul smelling substance. The compound that is from isocyanide of this foul smelling substance. And the reaction, I can stand for reaction, is known as carbylamine reaction, or we can say isocyanide test. Isocyanide test. And it is also very important. It is used as a test, used as a test for primary, amines. It's very important to note that secondary and tertiary amines, secondary and tertiary amines do not show this field. So if you are going to react an amine and if it is not reacting, so it will be either secondary or tertiary. The reaction is very easy. If you have a primary amine that is R and H2, and you are going to react this with chloroform and ethanolic, that means alcoholic potassium hydroxide base, and heat it, then you will be getting RNC, that is isocyanide, plus the salt, plus this. I think it's very easy. Then we will go for reaction with nitrous, reaction with sulfonyl chloride. Let's see. Let me know when you're done.
Done, sir.
Very good. So it's very easy. For the next week, next reaction is basically reaction with nitrous acid. Reaction with nitrous. So it will be reacting with in different manner. You can see the first one, we are going to talk about primary amine. Primary aliphatic amine. See how it is going to react. So if you have R NH2 and you are going to react with nitrous acid, that is HNO2, or you can say NaNO2 plus HCl, then you will be getting a diazonium Rn2 plus Cl minus, which will be highly unstable. So you are going to hydrolyze it, or you will be getting this N2 and Cl minus will be eliminated and it will form OH 4 plus and 2 plus H plus. What I want to say is that this will have two parts, H plus and OH minus. So this OH minus will be directly going to this, and 2 will be the less, and Cl minus will go with this H plus. Same happens with this aromatic amines, but due to aromaticity, it will not hydrolyze because it is already stable. So as you can see, this is your C6H5NH2, which is aniline, which will be in resonance. And if you are going to react this with same nitrous acid, NaNO2 plus HCl, and temperature should be 0 degrees centigrade to 5 degrees centigrade, then you will be getting C6H5N2 plus Cl minus plus NaCl, and it doesn't need to hydrolyze because it is stable. And this is your salt, a salt that is known as benzene, diazonium chloride. This is your anode. And primary secondary reacts in different manner that we don't need to explain.
Done, sir.
Very. Now see, the next is reaction with aryl sulfonide chloride. That is basically C6H5 aryl SO2 Cl. This is the formula for aryl sulfonide chloride, which has a name C6H5. If you are going for this, just let me write it here. AR. That is stand for aryl. So if I'm going to take this as this benzene sulfonyl chloride, that is C6H5 SO2Cl, which is also known as, we can write, which is also known as Hinsberg reagent. Hinsberg reagent. It reacts with primary and secondary elements in the same manner, primary and secondary to yield or to produce an ethyl benzene sulfonyl amide. So it's very easy. You can see the reaction. This is your benzene, sulfonyl, and this is your chloride. If you are going to react this with primary amine, what will happen? You can see you just need to remove this HCl and you will be getting your product. Double bond. This will be directly connected with nitrogen, and this is a name. N-ethyl benzene sulfonyl chloride. Sorry, not chloride. It is amide, and it is soluble in base, soluble in alpha. So this is reacting with primary amine. Let me know when you are done. Are you done with this?
Yes, sir.
Okay. You can see the secondary amines, how the secondary for the secondary amine. This is your main sulfonide chloride. This is your CPH5. Again, the same. You need to remove this. This HCl. You will get your product. There's a name that is N, and diethyl. Benzene, sulfonamide. So steroid does not react with urine. Amines do not react with benzene sulfonide. So this is it for today. In the next class, we are going to do electrophilic oxidation reaction and then diazonium salt. Then it will be over.
Yes, sir.
Let me know when you're done.